Welcome to Study Loop.
Okay, so we're asked to use quantifiers and predicates with more than one variable to express these statements. So for part A, we have that there's a student in the class who can speak Hindi. So there exists some student X such that let's let S of X comma Y mean that X, or S of X comma Y mean that X can speak Y. So if we do, there exists some student X such that the student can speak Hindi. This is what we want. Okay. Now for part B, we have in the class sport. Okay, let's let P of X comma Y mean student X plays sports Y. So we're saying that every student in this class plays some sport, so that's for all X P of X comma Y. Oh wait, we also need to say that they play some type of sport, so there exists some Y such that P of X comma Y. Okay. Now for C, we have some students in this class has visited Alaska but not visited Hawaii. So let's let B of X comma Y mean student X has visited Y. So if we say that there exists some students such that they have visited Alaska, so that's V of X Alaska, but has not visited Hawaii, we have and V, or the negation of V, right? So if they visited, the negation is they have not visited Hawaii. Okay, we are on D now. So for part D, we have all students in this class have learned at least one programming language. So we have all students, so that's for all X. There exists some Y, which is a programming language, such that let's let L of X comma Y mean that student X has learned language Y. So we're going to have for all X, there exists some Y, such that L X comma Y. For part E, there's a student in this class who has taken every course offered by one of the departments in the school. Let's let E of X comma Y mean that student X has taken all courses in department Y. So our statement becomes there's a student, so that there exists an X such that there exists some Y, where Y is the department, such that E of X comma Y codes. F, we have some students in this class grew up in the same town as exactly one other student in this class. Such that T of X comma Y means X grew up in the same town as Y. So then we have there exists some X, there exists some Y, such that X is not equal to Y, and T of X comma Y, and for all Z, T of X comma Z implies that X is equal to Z or Y is equal to Z. Okay, now for G, we have exactly class has started with at least one other student in at least one other chat. So let's let G of X comma Y comma Z mean that student X has chatted with Y in group Z. So we have for all X, there exists a Y, there exists a Z, such that G of X comma Y comma Z.